Hello students, welcome to CHM 122.2 class. Okay, so this afternoon I'm going to discuss the second part of your activity 1, which is the determination of vitamin C in pitch sample solution. So what you did in your activity is that you measure known volume of your sample, and then you add this 5 ml potassium iodide followed by 4 ml hydrochloric acid, which is 2 molar, and 3 ml of starch solution. We add hydrochloric acid because the requirement for the titration is the solution should be slightly acidic. We add starch because starch here acts as an indicator. In the presence of iodine, starch turns our solution into blue color. Now, what happens during the reaction? Okay. Now, remember, in your sample, you add potassium iodide and you add hydrochloric acid. So, sa potassium iodide, only iodide ion ang mo participate sa redox reaction, while in hydrochloric acid, only H plus will also participate. Now, our titrant here is potassium iodate, no? But during the redox reaction, only this iodate ion will participate because potassium ion do not undergo change in oxidation number. So, this potassium iodate here, you place this in the 50 ml burette, okay? Now, during the titration process, this potassium iodate, although siya ang atong titrant, there is no direct reaction with vitamin C. Instead, the potassium iodate reacts with the iodide ion and hydrogen ion from our vitamin C sample solution, generating a free iodine substance. Now, since this iodine substance is mixed with this vitamin C in our sample solution, then vitamin C reacts or readily reacts with this generated iodine. And this equation here represents the reaction of vitamin C with the iodine generated from the reaction of potassium iodate and iodide ion in the presence of an acid. Okay? Now, at the start of the titration, you notice that the color of our solution here is colorless. That is because at the start of the titration, it is the vitamin C is the one that is present in excess amount, while this iodine here is present in lesser amount. So all iodine generated is totally consumed by the vitamin C present in our sample. But at equivalence point, no more vitamin C. Okay? No more vitamin C. Once the color of the solution turns blue, buot ipasabot na ang na-detect sa atong starch solution is the presence of small amount of unreacted iodine. No? Wala na siya vitamin C nga ma-react. That's why ang starch na ang mi-react sa atuhang iodine. So, this turns the color of our solution into blue. So, when these things happen, we have to stop our titration because the color of our solution signals us to stop. Now, how do we calculate the milligram vitamin C in our sample? Now, when we calculate, basta gani titration process, now this is titration, iodimetric titration. Our first entry in the calculation is molar concentration times volume of our titrant over volume of our sample. Kung ang atong gi-measure is volume. But kung ang atong gi-measure is mass, our first entry is molarity times volume of our titrant over mass of our sample. Now in this case, we measure known volume of our sample solution. That's why our first entry is molarity times volume of our titrant over volume of sample. Now, take note that our M here is millimole KiO3 per ml KiO3. This volume here is ml KiO3. So multiplying M times V, this will give us unit millimole KiO3 over ml sample. Now we have to cancel this millimole KiO3 because our goal here is to calculate milligram vitamin C. There is no direct relationship between potassium iodate and vitamin C. Instead, ang potassium iodate here has direct relationship with iodine. That's why from millimole potassium iodate, we transform it into millimole iodine. Okay, because for every 2 millimole of potassium iodate, this requires 6 millimoles of iodine. That's why we multiply this by 6 over 2. So we can cancel unit of millimole potassium iodate here. Next, we have to cancel millimole iodine using the second equation. We multiply this by 1 over 1 because for every 1 millimole of vitamin C, this requires 1 millimole of iodine. So millimole iodine here cancel. Now we have to change this millimole vitamin C into milligram vitamin C by multiplying this the molar mass. The molar mass of vitamin C is 176.124 grams per mole. But this is also equal to 176.124 milligram of vitamin C per millimole of vitamin C. That's why millimole vitamin C here will cancel with this. So if we are going to simplify up to this point here, the unit of our resulting calculation is milligram vitamin C per ml. Now, take note, you are required to calculate milligram vitamin C in 100 ml sample. So, to cancel this ml sample here, we multiply this by 100. Ang atong 100 here is natabunan, no? So ml sample over ml sample cancel. So, the unit left here is milligram vitamin C. Okay, so thank you.